All right, so here's what we got. We have the kind of this is as easy as it gets. Y equals X. It looks confusing, but it's as easy as it gets. Okay, so basically what it does, this is an equation, right? We've talked about what those are, right? The rule is, here's the rule. In words, we could say stage number, right? Remember that was X, remember that? And then times 1. That's what this rule is saying. Because there's a 1, there's an imaginary 1 here out front. It's just not written. Does that make sense? Georgia, yeah? Your question?
Isn't it the same as the other side?
It is this, you mean like this?
Like, both of the rows, isn't it the same numbers?
They are the same. Not quite, because they're going to do different. So this rule over here, if you look here, Georgia, that's a different rule.
No, like the first row.
Oh, here? Like this?
And then the other side's the same thing.
You mean here? Is that what we're saying, or no?
She means that y is going to be the same as the.
Oh, very good. I see. So you're foreshadowing. I see. Yes. Yes. Why is that the case? Because we're multiplying by 1. I see, Georgia. I see. I'm too ahead of myself. Okay.
Wait, so 0 would be 0, 1 would be
Yeah.
2, or
What?
1?
Yeah. Stage number.
2 would be 2, 3 would be 3.
Yeah. Stage number is all these, right?
And then y equals x plus 2 would be.
Okay, hold on. Let's not get carried away. Let's just 1 sec. We're doing one thing at a time here. So if I plug in the stage numbers into my rule, I get 0, 1, 2, 3. Does everybody agree?
Yeah.
Okay, so then you can go plot those points. 0, 0. 1, 1 would be here. 2, 2 would be here. And 3, 3 would be here. There's your line. Okay. We're going to do lots with this, okay, including what the graph. Does the graph just magically stop here at 0, 0? Or do you think it continues backwards? Okay, so we'll spend some time doing that separately, but for today, let's just do that, okay?
That's why if you see the slope, like a graph with a slope, and you see that type of graph, it goes like this, and then on the other side it does the opposite.
Yeah, it does the opposite.
Monkey funky.
Okay. Can everybody see how we got that? Here are the points, right? 0, 0. Here, I'll 0, 0, 1, 1, 2, 2, 3, 3. Now, I do this for a reason, okay? We're gonna do the second one now with the exact same principle, like rules, what we're trying to do, okay? So we're gonna go, here are your stage numbers over here,
Bingo.
right? Except the rule has changed this time. What's the rule? I can write it. Okay, yeah. Let's write it in words underneath, just so everybody knows, right? We're gonna take stage number. Hey, Liberty. Stage number, right? It's multiplied by 1, so it's still times 1, but then I'm gonna add 2 plus 2. So we see that? So I plug in my stage numbers, right, into X, because that's what I'm doing. Right? And so what do I get? If I plug in 0 here, what do I get? 0 plus 2. So what's my y?
2.
Okay, good.
And then 1 would be 1 plus 2, if you use the prerequisite, and then 1 would be times that.
Okay, I actually think most of you are okay with this, right? From what I've seen walking around the room. Okay, we're just doing 1 plus 2, 2 plus 2, 3 plus 2. Can everybody see? Yeah? And all your answers are going to be 3, 4, 5. Okay, so this is kind of the fun part now. Right? I'm going to plot these points. What's that, buddy?
Number 1.
What? So we plug the 1 in up here. So I get 1 plus 2.
What is the H stand for?
Oh, it's not H. Sorry, buddy. Sorry. It's a plus sign. Okay? It's not an H. Sorry, guys. It's a plus sign. Okay? So you're gonna go plot these points now.
The fourth one's interesting.
Oh. Well, let's.
I'm not thinking about the fourth term, I'm thinking about the fourth, representing a linear problem in multiple ways.
Oh, I see. Okay. You're just ahead. So,
Yeah.
there's 0, 0. Oh, am I plotting 0, 0 this time though?
No, you're playing it as a 2.
Oh, good. So 0, 2, and then what? 1 and 3. Oh, keep in mind, it's good that we're talking about this. Be careful. Some of you flipped these values on your quiz, and I said that. Some of you were plotting y and x, so your graph was like opposite. You be careful. It's always
Your
X.
ones show up way clearer than ours. Ours are like poopily printed.
Oh yeah, no, I'll try fixing it now.
You can barely see them.
Yeah, it's the printers.
If you print them a little bit bigger, the print resolution should be fine.
I think I'm gonna like when I put these graphs in there, I'm gonna like increase the contrast or decrease the contrast so you can see the dark lines a little bit better. Okay, I'll start doing that more. Okay, then I gotta plot 2, 4 and 3, 5. And there's my line. Now, can anybody tell me, relative to the last question, is there anything interesting going on?
There's +2, and then you don't start at 0. It's the non-variable or something
What do we call the non-variable?
in the independent. I don't know.
The non-variable. No, we don't.
What's the-
We don't want to walk around calling it the non-variable. It's too much. What do we call it? Starts with C.
Constant.
A constant.
Whoa,
Whoa.
crazy.
Okay, let me just try something here for you.
Constant is the +2.
Yeah, the constant's the +2, which represented what yesterday?
Something.
2 red tiles, 2 red tiles, 2 red tiles, 2 red tiles. That's the constant. Let me just show you something. What if I took this red line from over here? What if I took the red line from the first one and I graphed it on the same graph? What would you expect to see? 0, 0.
It's the same graph. It's just it starts from a different point.
Oh, really?
Wait, I don't know.
That's interesting, isn't it?
Uh,
By what do you mean starts at a different point?
because there's no constant in the first one.
There's no constant in the first
Oh, the
one.
difference between an independent and a dependent graph or something. I don't know.
It was partial and
partial and non-partial.
partial and direct, I think.
Yeah.
Something like that.
Same thing.
Yeah, that's what we were talking about. That's what we were talking about yesterday.
Bazinga.
Okay? But how can I tell where I start my graph without actually doing the table of values? Can somebody show me from the equation, how do I see where I'm starting?
Oh, you just look at the +2.
Does that make sense to everyone?
Yes.
I want to see everybody. Yes, yes,
I'm
yes.
looking at you.
Okay, well, if I look at the equation,
+2 because x return number and so you.
where do I start my graph?
2.
At 2.
2b.
That's important. I promise you it is. Okay,
Is that going to be on the summative?
maybe. No, we'll do it. We're just gonna keep, this is a separate unit. Your summative will be on like
Ratios?
scatter plots, ratios, percentages, things like that, okay? That's it, buddy. That's it. What do you want to do the next one? We'll do the next one?
Oh, y equals half the term number.
Hold on, just, yeah, I like the language you're using. Okay, but let's do the next one. Now what? Can we, just for fun, can everybody just draw the graphs on here? All of them.
All of them?
Yeah.
That might be against the law. I don't
Well, just for curiosity, well, I'll do it in different colors. You guys, maybe you don't have to. You just watch me, okay? Well, I'll plot all these lines on here because I can copy paste them. Watch how easy this is. Hey, watch. Watch how easy this is. You guys don't have to do this. You just watch. Okay. there's our first two questions, okay? Now, let's take a look at our next rule, shall we? Our rule being this.
I know.
Just 1 second. I haven't asked the question yet.
I know.
What's going to happen?
I know.
Harry?
Yes. Please answer the question.
Sure, answer the question.
Okay, well, you're starting at 2.
Oh, wait, stop. Why are we...
And also.
1 second. I know there's an also, but let's just pause for a second. Why are we starting at 2?
No, because plus 2, there's.
Plus 2.
It's
Okay.
not dependent on the
Okay.
number.
Am I going to plot any points right now?
Yeah.
Which-
Yeah, you're gonna plot 2. Plot 2.
Which one am I plotting?
You're. Wait, bottom left.
If x equals 0 and I plug it in here,
Oh,
I get 2 times 0
is 0 and then.
plus 2.
2. So it's 2.
So okay, I'm going to go start up at 2.
I didn't know
All right.
that.
What's next?
1 times 2, because times the term number, 1 is the term number. so
Okay.
Times 2 is 2 plus 2, so it's 4.
So we're taking this and we're plugging it in for x, and we get 1 times 2 plus 2. What is that?
4.
Okay, so let's go plot that point.
I gotta grab my pencil.
Sean, are you looking? Or are you playing games? Okay, this is very important. There is like,
Ready?
if there's a time I need you to push through like boredom or whatever.
This is not
this
boring.
no, this is kind of exciting actually.
Well, I just like.
And keep in mind what we spent the most of the morning doing. Do you want to type in tables of values all the time, like go plot graphs? Like that's boring.
Yeah,
I'm trying to give you the fast way to actually answer questions like this.
you just need the thingy. You just know how. You need to know how to decode the term.
Yes. Okay.
When you know how to decode the term language, you can just.
Okay, so can I, let's just look here for a sec. 2, 4, let's plug in 2 and see what happens.
Times 2 plus 2.
Okay, so that's what?
6.
2 times 2 is 4,
4, yeah, plus 2.
plus 2 is 6. And then what? 3 times 2 is 6,
Plus 2 is 8.
8. Okay. Can we, for a sec, go plot those points? So 0, 2 we've already plotted. Then we're going to go to 1. And I'll do this in, what color do you want? Who wants what color? Oh, okay. Green. So, oops. So I'm starting, here's the green line, okay? We'll do all these in green.
It's a steeper slope.
I'm still on the eraser. Ooh, you be careful with the words you're throwing around there. We haven't talked about that yet.
Are you talking about slope?
Not yet.
Not yet.
We're going to.
Oh no.
Oh, yes. Okay. 1 and 4 is where? Right here. Does everybody see that? And then, are you in? Oh, you're in agreement? I was asking if we were in agreement.
Oh, what?
2 and 6,
Yes.
and 3 and 8. Okay, what's the problem with my green line now? Not that there's a problem, but
Don't bully the graph.
don't bully the graph. What's different about it?
The steeper slope. Because it goes up by more each time. Oh, I feel like I'm gonna pass it.
What do we notice?
Are we timesing the next one by half?
Just relax a sec. When I got there, I don't want to do the next one in the normal way. I'm trying to pull you along so we like do it in the way that I want you to do it. Okay. What? This would be so much better if this interacted with in conjunction with.
Yeah.
What's going on here? And Sean, I know you know how to do this. How do I get from here to here? Plus 2. What about from here to here? Add 2. What about from here to here? Okay, so let's go and take a look at our graph here. How do I get up to the next vertical point?
Times it by 2.
Not times it by 2.
Plus 2.
I move up 2. How do I get over?
Go over by 2.
Is it 2 or 1?
1.
let's try it again. Up 2,
Over 1.
over 1. Up 2.
Over 1. That's the
I didn't just make that up. We did the points. Now, can we for a second
Going
find why is that the case? Why does this work? Up 2, right 1, up 2, right 1, up 2, right 1. Why does that work? It just does, but where is it? I guess my question should be, yes, it does, and it will always work. How do I know it's up to right 1 instead of up 10, left 40?
Oh, because I don't know, they're multiple.
Just take a look at your rule for a second. Just stare at that. We've identified one piece, right? Everybody knows where we start, right? Where do we start?
2.
2, so I went started at 2. So where else could I find up to the right 1, up to right 1?
Oh, well, the term number only goes up by 1, and then the thingy, it goes up by 2.
Okay, that's
It's
even,
times 2.
that's actually even better than I was hoping.
Really?
Yes. Let's just pretend here for a sec.
We'll pretend.
Let's pretend that I'm gonna draw an imaginary 1 here.
Imaginary.
Can everybody see
No, I can't.
how the rule works?
Yes, I can. Oh, yeah, no.
This is what we call slope.
Whoa. That's a word.
And how do we measure slope?
Are we still imagining? Oh, in degrees. Wait, percentage?
No. Well, I guess you could actually. Yes, you could. That's the thing.
Degrees?
Have you ever driven around on a road and then gotten to like a spot and it says 10% decline?
Yeah.
That's a slope.
Oh, a grade.
A grade.
10% grade.
I'm just doing this. I'm just running through this one a little more. I'm just talking about. You can just sit and listen. Okay. Okay. Harry,
Yes. Grade?
what do you think grade refers to?
Oh, like,
How far something increases
or decrease?
or decreases for how far it goes. So we call this rise over run. That's slope. Everybody should probably make note of that. It's important. Okay? So if I look at my number that I drew in green here, well, that's not good. Let's not do it in red.
Wait, rise, wouldn't you divide?
Hold on, we're not dividing. Well, I mean, it is saying to divide, but you're not actually going to do the division.
Alright.
What's it saying? It's saying, if I relate it to this, what?
I do that.
I'm going to rise to
Rise 2, go over 1?
over 1.
Oh, because it's 2 over 1.
Sean, do you see that?
That makes sense. It's pretty crazy.
Magical.
Not magic, it's math, but
It's
yeah.
math magic.
Mathical.
Okay, can everybody see that though? Okay? Rise over run. Rise over run. 2 over 1.
Is this when graphs get fun?
Yes, we're gonna do the next one. I actually don't even really want to do the table values for the next one.
Why not?
Because it's messy.
Decimals, right?
Because the decimal, I don't really want to do decimals.
Why not?
So let everybody go over and look at the next one.
Decimals are fine.
Okay, I'm gonna copy paste these.
Wouldn't you have 0.5 and then minus 2?
Just hold your horses.
I can't hold my horses when it's right there. You don't have horses. It's like a...
Alright, here. I want to do this in a fast way. No, hold on a sec. Everybody just wait. I do not want to do this with the table values. But you can. But what's the matter? You're going to get a decimal out front. I don't really want to do decimals. But can anybody tell me, where am I starting?
-2, so in the...
Shh. Where am I starting? You look like an airport Land in airplanes now. Okay, where am I starting, everybody? -2. So where is -2?
On the opposite side.
Right here.
It's on the paper.
It's on the paper somewhere. In fact, there's lots of -2s on the paper. So I'm starting here. Now, here's what I want you to do. I want you to produce the line without the table values. I start at -2.
It's like taking away my legs.
What's slope equal to?
Slope is equal to rise or run.
Rise over run.
It's gonna know that.
Where's that come from?
The planet? I don't know. Slopes? What? Oh, you already did that.
What?
No, that was.
Where's it from? Where's it from?
Oh, wait.
The fraction.
1/2, it's still.
So what's it telling me to do?
Down, or over 1, down.
Ah, rise first.
Oh, up 1/2.
Yes. So where am I starting? Where am I starting?
At 2.
At
Negative
2?
two.
-2.
You know what I mean.
I know what you mean, but okay. So I'm gonna start at 2, and what's it telling me to do?
Raise 1.
I'm gonna go up 1,
Up 1.
and then right 2.
Oh, up 1, right 2.
Okay, let's do that. Up 1 takes me to here. Right 2 takes me to here. Up 1 takes me to 0. Right 2 takes me to 4. Up 1 takes me to here. Right 2 takes me to here. Up 1, right 2. Look how much faster that is. Plot the lines. Or connect the dots. What's different from the blue graph to the other ones?
Oh, we're starting somewhere. We're starting below thingy.
Okay, good. We started at a lower value, so that's good.
Started at negative numbers.
Started at negative numbers, and then what?
And we didn't use the table of contents.
Can we just for curiosity's sake, what was the red graph? Does everyone remember what the red graph is?
Oh, no, I don't.
Well, I know what we did. I don't.
The red graph was this one.
We didn't add any per term. It's just hanging out.
The red graph is as easy as it comes.
We start from 0.
The slope's not 0, careful. Slope is what?
Oh, 1.
Over 1.
1 over
So
1.
I went up 1, right 1, up 1, right 1.
Yes.
Up 1, right 1, up 1, right 1, up 1, right 1.
Very linear.
Well, they're all lines.
Oh, yeah.
Now, is everybody okay? Let's do the last 2.
Very intuitive.
Let's do the last 2. And I'll show you a funny video.
2 times 3. Oh, you don't even give us that thingy.
No, I don't give you. I don't want you to do the table values.
I like the table of values.
I know you do.
Well, stop bullying.
Look how fast this is.
It is fast, but I also like
Fast. You want fast and efficient.
I like legs. Well, I like having a leg.
You don't like graphing.
I don't like graphing
Well, I don't know why you don't like graphing, but you like tables of values.
because they're fun.
All right. Well,
I like
sorry about your luck.
times the term number and then minus.
Where are we starting for this one?
Starting at
Just wait for somebody else to answer. Where are we starting? Thank you. -3.
-3. Oh.
Where's the -3 from? Right here. And then what? What's my slope?
3 over 3.
Oh,
Wait.
what's 3 divided by 3?
1. 1 over 3.
Is that what you see that? Not closer. We're getting closer. It's not 1 over 3. It's 3 over.
3 over 1. That's what I meant.
Okay, so it's always rise over run, which is
Makes me think of like diarrhea or something.
up 3. We're gonna count up 3. 1, 2, 3. Right 1.
Is it the wait, what? How are we there? Oh, up 3 over 1, yes, that's that.
Up 3. Right 1. Up 3. Right 1. Up 3. Oops. 1, 2, 3, right. That seems off.
Yeah, that does seem off.
Because I only counted up 2 in the last one.
Wow, that's not very nice.
1, 2, 3, right one. All right.
Bingo, bango, bongo.
How's that, everyone?
Where's my ruler?
We'll do one more, and then I want to show you something.
You can make us do it on our own.
Yeah, try it on your own. Take 2 minutes. Don't be so stressed. It's one question.
Sean, pay attention to me and then you'll do it. Okay. I'll try.
Okay, you guys try this on your own. Okay, then we'll take it up in like 2 minutes here, okay?